Awesome. Hi, everyone. My name is Patrick McCorry, and today I'm going to present What's L2s Anyways, which is the greatest grammatical title I've ever been given. So what I did notice in the schedule was there's a lot of technical talks for the past 3 days. I mean, this is always technical, but I want to step back a bit and really talk about the motivation for why L2s are really exciting and why we need them. So hopefully you'll get an idea of why we care about stuff like optimism, Starkware, Arbitrum at all. So as everyone's probably aware, cryptocurrencies do not scale. They support on the magnitude of 15 transactions per second, and it hasn't really changed much in the past 11, 12 years since at least Bitcoin has existed, and the past 6, 7 years for Ethereum. And as we're all aware, I guess as well, once we surpass 15 transactions per second, once we go above the ceiling, the fees on the network skyrocket. So this was a screenshot that I took from a few months ago where Ethereum collected $60 million in fees in one day. And actually, I think yesterday it was $40 million because of some NFT drop. And then when the fees skyrocket, no one really wants to pay $400 for a single transaction. This is far too expensive for most people to use these networks. On the flip side, there has been work towards scaling blockchains. And there's various, blockchain protocols out there like Solana. They can do 65,000 TPS. Polygon claim to do 7,000 transactions per second. And Avalanche say they can exceed 4,500 transactions per second. So if we can really go, warp speed for these blockchains, then why can't we do that for Bitcoin or Ethereum? What's the problem? Surely I don't even have to give this talk because the job's already done, right? Well, just like the cat, no, the job's not done. And there's a very good reason why we can't achieve 45,000 transactions per second on Ethereum. So if we step back a bit, what does it mean to be decentralized? And in the Ethereum world, we tend to think about this one common goal. A percentage of the world's population should be able to verify the blockchain's integrity in real time and to validate all transactions. This is the trust but verify paradigm. I have the sort of trust the block producers, the order transactions, but I should hold them accountable and verify everything they do. Ideally, anyone in the world can download Go Ethereum, run their software, run the node, connect to the peer-to-peer network, and start validating Ethereum transactions. Regardless if you're in Indonesia, Argentina, Chile, Canada, Greenland, Norway, the little island at the top there, it shouldn't matter really where you are. You should always be able to verify, given some hardware constraints, the Ethereum blockchain in real time. And all of our powers can combine and secure the network and to keep it decentralized and remove any single point of failure. But because of this goal, we have this artificial constraint on the network resources. We have to constrain the CPU, we have to constrain the storage, and we have to constrain the bandwidth because we want to be able to, as I mentioned, like people in Indonesia, Africa, Chile, we should be able to verify these, the network with reasonable hardware. You shouldn't need a supercomputer or AWS to do it, that terrible maxi meme. But because of those constraints, we end up with a computer from the 1970s. It's slow, it's very expensive, and everyone has to share it. And this is, I believe, a photo of Vitalik with his old computer. And that old computer is probably more powerful than Ethereum. So what do we do then if we have this goal for decentralization? Should we just give up on scaling the network? Well, we know we can't give up on that, obviously. So one point to make is if a user can't afford to use the network, if you have to pay $400 per transaction, then why should any user even care about validating it? If I can't afford to use the network, I'm not going to run a node because I just don't have any coins on the system because it's too expensive. So while we want to have decentralization such that anyone can validate the network, we still need to work towards the goal to make sure it's affordable for anyone to use it. So anyone in the world can have the right to have custody of their own funds and not to trust a third party. So scalability, it is about increasing the network's throughput. But for blockchains, we have to adhere to the same set of resources and still at the same time increases throughput. That is the ultimate bottleneck for blockchain scalability, which is why many other blockchains give up on this constraint, and they do 65K transactions, but really they give up on decentralization. And we don't want to do that for Ethereum. So there is a third way, off-chain protocols. And the idea is very simple. Why don't we take our assets that are on Ethereum, move them to another network, and just transact there? So we just take transactions away from the main chain, we take transactions away from Ethereum, and we just transact on a different network, but using the assets that reside on Ethereum. That may sound a bit weird or funky. So my question is, have you ever deposited coins onto an exchange or an online service like Coinbase, Binance, or Bitstamp? If you have, then in a way, you've used an off-chain protocol. Now, the problem is these services are fully custodial. They can freeze, confiscate, lose your funds. We can't audit them. Their layer 2 database is opaque. It's not publicly auditable. Are they running a fractional reserve? We have no idea. It's just not publicly verifiable. But of course, we trust these services to also order transactions. So if I submit 5 trades, Coinbase in this example would order the trades and execute them. And ideally, I should be using funds that reside on Ethereum. And if you step back a bit, this is sort of what it looks like from Ethereum to Coinbase. What we're really building is a bridge. There's a bridge contract in the middle. It has 3 functions in a really simple world. It can deposit, withdraw, and update account balance. So as a user, I'll deposit coins into the bridge, and the bridge contract will notify Coinbase to unlock my fund, or to create me an equal number of coins on the service. When I want to withdraw my funds, I ping Coinbase and I'm like, Coinbase, let me withdraw my funds. Coinbase will send data to the bridge contract that will authorize Alice to withdraw 1,000 ETH. And then Alice can call the withdraw function and withdraw her funds. So in a way, the bridge automates the deposit and withdrawal process. So this sounds really cool. We are technically scaling Ethereum in a way when we use the Coinbase, Kraken, Bitstamp, etc. What's the general idea that's going on here? We're actually just bridge engineers, and we're connecting blockchains to Ethereum. We have Ethereum, we have lots of different bridge contracts, and we have this wonderful galaxy out there of different blockchain networks and services. And the trust assumption really boils down to, when I transact on another network, what really matters is how the bridge contract is convinced about Alice's new balance. Okay, so if I transact on a network and I get 1,000 ETH, I flipped some JPEGs, I sold a penguin, I get 1,000 ETH from that other network. The trust assumption is, how does that other network inform the bridge that I now have these coins and I can withdraw them back to Ethereum? It ain't much, but it's honest work overall. So let's go through some of the trust assumptions. The first is single authority, one ring to rule them all. This is Coinbase, Bitstamp, and most of the exchanges. It's up to that single authority whether you can withdraw your funds or not. Another bridge is the multi-authority bridge, K of N parties. This is the RSKs and the liquids. The idea is that I lock funds into the service, and then there's K of N parties. You can imagine 5 out of 10 people. They all have to agree that I can withdraw my funds from the network and bring them back to Ethereum. So we distribute trust. There's now several rings that rule them all, but all these rings have to work together. I forget the Lord of the Rings equivalent for that. And then the third one is a crypto-economic bridge. So again, they typically have this dynamic set of parties, K of N, but the idea is that every party can appoint themselves, they can stake on the network, and they have skin in the game. So I could lock up $1 billion, and then I can start helping people withdraw their funds from, example, the Polygon network. And because I have a large stake in the network, I should be honest and not, try to steal people's funds. Because I have such a large stake, I want to see this succeed. That's the basis behind how those other bridges work. But can we do better than this? because in every example, we still have to trust one party or multiple parties to protect our funds in the bridge. And in blockchains, we want to trust minimize. We want to remove intermediaries. We don't want to add intermediaries to move from one network to the other. So this brings us to the layer 2 bridge, the non-custodial bridge, where we only trust Ethereum and the bridge contract to protect our funds. This will assume that Optimism, Arbitrum, ZK Sync, Starkware, Loopring, all of these L2 protocols, if those L2 protocols are fully compromised, posting invalid transactions, trying to steal our funds, the bridge contract is there to protect us, and it will never allow those other networks to steal our funds if we've locked funds into that network. And how do we do this? Well, at a high level, the update account balance now has two arguments. One is the data. What was Alice's new balance? And the second one is evidence. The operators of another network has to provide evidence to the bridge contract on Ethereum why this data is true. Why does Alice have 1,000 new coins in your service? And that's really the simple trick. It's providing evidence. The bridge contract will check it. If it's convinced that all is well, the other network's not compromised, the evidence is correct, it will then allow Alice to withdraw her 1,000 coins. And in the worst case scenario, the bridge contract can just forgo the network, forget about it, ignore it, hit crisis mode and allow everyone to withdraw their funds. A way to visualize it is sort of like boxing. You have the adversary, they're trying to do censorship, invalid transactions, withhold data. And you know what? Ethereum's fighting for you. It's basically punching it in the face and saying, no, you cannot steal our users' funds. And that is why layer 2 protocols are so damn exciting. So a layer 2 bridge at a high level allows us to transact on another network with assets that reside on Ethereum while retaining, that should be retaining, not retraining, security of Ethereum. It is the bridge contract and not the authority that protects your funds. And in this way, we're actually truly scaling Ethereum here, because we're taking the decentralization, the security of Ethereum, and applying it to the other networks. And at the same time, Ethereum's not processing most transactions. It's just protecting your funds. That's its only role. And you transact somewhere else, and you still have Ethereum security. And what's also exciting is that this old dream of sidechains is now alive and well. The sidechain dream came from a Blockstream paper in 2015. We could build experimental blockchains, move Bitcoins onto those blockchains, and work out how we can scale these networks. Bitcoin can never do it, so obviously Blockstream can never pursue that dream, not in the way that it should have been pursued. But now on Ethereum, we can. All these new blockchain networks, ZK Sync, Arbitrum, Loopring, Starkware, Optimistic Rollup, or Ethereum, they're all new blockchain networks and they're all unique. They have a different validator setup, different blockchain protocols, different smart contract environments, and even special scaling techniques like ZK proofs. So we can now experiment with all these really cool scaling protocols on these different networks, work out how they, test them, see how they work in practice, work out the quinks, I think that's the right phrase. And then if they really work, we can then apply it to Ethereum. And at the same time, we can experiment while still keeping Ethereum security. And that's amazing. So just to finish the talk, this is how you should visualize layer 2 protocols. Ethereum is holding out its hand. These layer 2 bridges are holding on to Ethereum and carrying along these new blockchain networks and allowing us to scale and make it affordable for anyone in the world to use these networks. And of course, there's the moon, because we're all going to the moon. I hope you enjoyed this talk, and to the moon. Maybe we'll find another moon cat.